One of my goals when undertaking this study was to see when technical communication emerged on the factory floor. I wanted to find out when it became a necessary part of industry. When did people other than the owners and upper management begin to use writing to communicate in order to keep the factory running? At Lukens Steel, this happened in the early 20th century. The shift was gradual, as first the working men and women kept detailed quantitative and qualitative data in books, and later began communicating in written and drawn notes. This lecture covers that shift. Towards the end of the 19th century, individual workers began to keep pocketbooks of various things, such as mill output, specifications for punch and drill orders, car records for incoming and outgoing material, etc. This is one tiny book that kept detailed information about the iron and steel output on the right page and notes about major events at the mill on the left. These notes included such things: mills standing idle, deaths of workers and fires, etc. This notebook was kept for specifications for plates to be sheared and shaped. Most of the notes were written in dark ink, but some were written in red pencil to draw attention to them. That the book was well used can be seen in the fingerprints at the edge. It's unknown whether the author was someone in the office or the person who made these parts himself. Before the end of the 19th century, record keeping had become necessary to track the increasingly sophisticated technologies that they were using. These are some books from the puddling mill that they used between 1870 and 1890, when they first made their own steel. This was the last time that individual men's names would be mapped to production. After this, the tonnage books were organized by chemical and physical features instead. Group work replaced individual craft work. Another form of record keeping that appeared before the 20th century was car record books. These were notes of arriving and departing railroad cars with their materials. They were eventually transcribed into larger books. This is the page from a car record book. It's an example of how literacy was becoming increasingly necessary in various parts of the operation. The men working at the plant would have seen other forms of writing in their immediate environment too, such as these indicator cards that were wrapped around a cylinder to test the power of steam engines. This was the machine that produced the cards. They could tell by the shape of the tracing whether the engine was functioning well, as at the top, or whether there were problems, such as at the bottom. Science was working its way into the factory floor as well. But most of the writing before the turn of the century was record keeping. They kept loose sheets on the factory floor of open hearth and mill output, and then brought them to the office where they were transcribed into ledgers. They also kept an ongoing record of defects, noting the type of defect and the foreman who counted it. This was useful for tracking down and solving problems. These records were transcribed into a defective plate record book, which collected valuable information about which defects were the most common in order to eliminate them. Overall, the plant had grown beyond the ability of any single person to have the knowledge necessary to operate it. Different people managed different parts of the plant, and they increasingly used writing and drawing as the glue that communicated between them. The foreman of each group gradually had to become an able technical communicator. This happened just after the turn of the century at Lukens Steel. I can't speak for other companies. When writing first emerged on the factory floor, it was a series of handwritten notes folded and addressed to the works manager, Charles Houston, such as the one seen here. There was probably an intraplant mail system. Houston kept these notes in his files with any accompanying documents, often attaching them using a pin. Sometimes the messages were relayed on to others. Here is a series of answers to questions that Houston had asked. He often prowled the different mill buildings himself, watching the machinery in action, but no one person had the technical ability to understand and operate the whole. It was too complicated. It had become a system of teamwork mediated by writing. Houston was the node at the center. Houston, fortunately for me, even kept scraps of paper his workers used to document their activities. The workers used writing, quantitative information, and drawing all at the same time to convey their meanings. It was a rapid way to explain problems and propose solutions across space and time between parts of the plant and the people who operated them. Some workers became very skilled at making exact mechanical drawings. For more information on the use of drawings and images at Lukens Steel, listen to my series, Images in Industry. The use of drawing as an aid to engineering was so important that it took me 3 segments like this one to explain it. For more information, of course, see my book. The odd thing is that, just after the emergence of technical communication on the factory floor, in 1911 to be exact, the workers' notes stopped. They were replaced by carbon paper and flawlessly typed text. A new worker had joined the force, the stenographer typist, who took over responsibility for taking dictation and making it into writing. After this point, the handwriting of the factory workers is seldom seen in the files.